Thank you, and good morning, good afternoon, or good evening, depending on where you are in the world. We're here to talk a little bit about security and shifting left, and really, ultimately, why security matters in DevOps. And we're going to start with a little level set. We're going to look at how the DevOps journey, DevOps transformation goes, and then we'll get into the specifics of how we can bring better API security. So let's start with taking a look at the J-curve of transformation, or how our DevOps journey goes. And usually what we see is something like this J-curve of transformation. And we start out with a reason for why we're going through this. There's some business driver that's causing us to level up our software delivery game, either to take advantage of an opportunity or to stay competitive in tough markets. But then we move on, and we start to add some automation. Very often our first step's automating our software build and deployment process. We usually call this, continuous integration, continuous delivery, continuous deployment, or CI/CD. And we start to deliver changes faster. Now, we start to deliver changes faster, but our environments may not be ready, and this can start to hurt, right? And our existing technical debt, our design decisions, those things can lead to challenges in this process. And so the more things that we automate, the more things that we need to validate that our automation is doing the correct things, right? And very often as we get to this process, it's kind of manual. We don't want to stay here. We don't want to live in this world. Now, as we improve our testing capabilities, and we start to reduce our technical debt, improve visibility into what's happening in our environments, and we adapt our application architectures to be CI/CD friendly, things start to get easier. But we still need to find more processes to automate and define more executable tests to validate our environments and reduce manual test points and manual inspection, right? And then we start getting to a point where we've iterated on these problems and things are getting smoother. We've reduced manual touch points, and we find ourselves capable of delivering more new work faster and more safely. Now, this J-curve is brought to you from the State of DevOps report. I call out some stuff from the State of DevOps report in 2018, 2019, and also some of the previous reports as well, so we can see a pattern of this information over time. But the State of DevOps report breaks companies into categories, right? They classify organizations as low, medium, high, or elite performers. And the differences mainly come down to the capability to deliver change. Now, I'm not going to spend a lot of time on the individual categories, and you can see from the slide some of the particular characteristics. But if you can deliver change in a consistent and automated fashion, you level up your organizational capabilities. That's why there's so much emphasis on the CI/CD process early in your DevOps transformation. Now, one of the things we're going to see is where you live in, where your organization exists kind of in these categories can very much impact how you respond to security challenges. Now, one of the things we don't see in the categories as we go from medium to high to elite is a large change statistically in the change failure rates and service recoveries as the lead times drop. And one of the things that's important to recognize is you don't need to deliver billions of times a day, right? That becomes a vanity metric. But what you do need to build is the capability to deliver software with confidence when your organization needs it, right? If you can build the organization, if you can build the confidence to ship from your master or from your main branch when you need it, you're getting towards that elite category. Now, some of the things that we see in these organizations, and you can see percentages of where people reply, based on where their organization falls. Automated builds are pretty much table stakes. So if you have a continuous integration process that regularly is building your software on each commit, at least on some sort of schedule, but preferably with every commit, that's really the first step towards stability and resilience in your development process. Then we start to add some automated tests, right? In order to work at speed, we need that safety net that automated tests provide. And you can see the test coverages rate rise as we move upwards in the different organizational categories. And then we get some, and then we've got some great content really around our testing story. For example, a service I'm very familiar with is Azure DevOps. And they have a wonderful write-up at aka.ms/shift-tests-left on how they moved from these long 24 to 36 hour nightly tests to 36 hours, not quite nightly, to being able to run 60, 70, 80,000 unit tests in 6 or 7 minutes. Right. And so when I say shifting left, I'm referring to moving the work closer to the time that we do develop and build, and further away, further before and earlier than deployment time. So if we think of a timeline from commit out to deployment, with the commit being on the left side, that we want to push our tests closer and closer there. Now, we start to see automated provisioning make an appearance. This further improves our ability to get new code running safely, helps us build out new test environments so we can validate things more thoroughly before we move to production. And then we also improve our deployment into production. And the fewer places that a person has to intervene, the better off we are. And we also see some automated security tests. And this is what we're here today to look at security and talk about security, especially around the API. But there are things that we can and do and should do to test our production and test environments to validate security. But we really need to look at how we can shift our security focus to the left. There's static code analysis tools, which are getting better all the time. We can look at testing our pre-production environments, but there's other aspects of security that we can shift left as well. And that's especially around the API boundaries we're going to learn about in just a little bit. And you can see there's a lot of capacity for growth in automated security test coverage amongst all the organization types. Now, another aspect that we see in a DevOps transformation process is how we build the capacity to do new work. How much time we spend on rework and security remediation and working on issues that come up. And one of the things you can see is that the high and the elite performers have freed up 20% more of their time to be able to work on new things. New things are the things that bring our organizations value. And so we want to get our engineering teams working in that category. We want them to have that free capacity and not working on old things, right? We want them working on new stuff. Now, something important to take a look at, and this is a statistic that has been consistent throughout at least the last 3 or 4 years that I've been reading the State of DevOps report, is that those organizations who have improved their ability to deliver changes quickly, they spend less time overall, by half, on remediating security issues. And there's a cost to all that rework. Right? There's a cost to your organization. You might think, oh, hey, we already pay the salaries and things like that. But if you're looking for a reason to be able to go to your management, go to your leadership about why we need to spend some time improving these processes and getting to a place where we're avoiding a lot of rework, you can take advantage of calculations like this to help bolster your argument why you should spend less time or why you should be focusing on some of these DevOps initiatives so that you can, enjoy better performance for your organization. There's also some security implications here and some costs that go over and above the cost of rework when we start talking about security flaws. And NIST has some good data about how much it costs to remediate security flaws, and then comparatively how much it costs based on when those flaws are found. And as you can see, it is way less expensive to deal with security flaws early in the process, either at requirements time or in development and early testing, compared to when it gets out into production. So now I think we're about to see a fantastic way to ensure that from the earliest time possible that we're securing our APIs from Isabel. So Isabel, I'm going to stop sharing and it will be all yours.
Thank you, Steve. All right. So we'll take from there. So yes, I'll just also take the opportunity to say hello because I haven't done that before, wherever you are. So we're going to focus us. Thank you very much, Steve, on the introduction here on the process. And we're going to focus now how we actually do and enhance automation specifically for API threat protection. So first of all, I just wanted to share some information about whether in today's world with the new architecture of applications and the overwhelming use of APIs, both for B2B integration or development of mobile or web applications themselves, we're seeing more and more problems and breaches and vulnerabilities with APIs, something that we report regularly on our community site, which is called apisecurity.io. So this is a real problem, right? By opening APIs and opening ourselves to partners, to third parties to come and consume our data and processes, we're opening ourselves to potentially problems because simply this is becoming the #1 entry point into any enterprise, either for internal consumption or for external consumption. So those breaches, and I really encourage you to have a look and follow this closely because you will see real cases of problems and why those are actually happening. And you will see that the most recurrent problems are linked to mostly and probably majoritarily the lack of input validation. For the past probably 20 years or 30 years, we've been saying, hey, when you create an app and you open it, don't trust anybody and any data coming your way, just validate it, make sure this is what you expect, make sure it doesn't contain things you're not expecting. But still, that problem is still there and very much the opening to a lot of issues. The second one, and this is more like typical of APIs, is data and exception leakage. So when we're directly interacting with an enterprise through their APIs, we're, in a sense, getting direct access to a lot of data and information. And if we can trick the API into giving us information that it is not supposed to give us, then that's like an easy way of obtaining and gathering information. And that could be just leaking some data we shouldn't leak, like this example I'm showing here on the right of a lot of information being linked through an API for the Venmo application in the US, or it can be that because we've been sending wrong information to the API, this API is actually not handling that information properly and handling exceptions properly and starts leaking key information about the implementation of the API itself, right? And the third aspect is really about broken authentication. This can happen for a number of reasons. It can be simply that we forgot to put protection in place because this is a dev or a QA environment and we have only put protection in place for production systems, or simply somebody hijacked an API key or hijacked some access token and is replaying it and using it to scrap some data again. So there's a lot of different things that can happen. Those are kind of the main three problems, right? And because this is happening and this API movement is really, this is here to stay. And as time goes, companies have more and more and more APIs to deal with and to work with, then this is really now becoming the #1 entry point into any enterprise, which means it's going to become something very juicy for hackers to use to try to evade information and get some information. So by in the next 2 years, so 2022 is like next door, right? It's just around the corner. This will be like the #1 attack vector according to Gartner as a specific analyst, but really this is like a consensus now in the market that this is happening. Now we're doing more and more APIs, right? So they're being developed very quickly. This is this content requirement by the business to expose more information, to have more applications, to have more functionality, more integration. So the developers really are today in this frantic race of developing APIs, and really what matters to them and to business in general is, okay, we have some functionality to deliver and we want to deliver that functionality most likely yesterday more than tomorrow, right? And what happens now on the security side is very traditionally the way security has worked for application security is we were developing our applications. They were evolving every maybe months or 6 months or even yearly. So security teams had a lot of time on their hands and the proper tools to actually analyze the applications that were going to be deployed and see what problems were inside and have the time to go back to development and fix those problems. So we had a lot more time on our hands and much less applications to deal with. But this is way behind us now, because now when we talk to prospects and customers, they're telling us, well, we have like 100, 200, 300. And as Steve was mentioning before, what has changed as well is rather than deploying every month, we're deploying every day. We want that agility, right? So development through automation and a lot of different tools has reached a very high level of agility that security has not attained. So development is kind of running around really fast here, and really security is struggling to catch up and being efficient at what they have to do, which is to protect our applications and our data, right? So in order to protect APIs and how we work, we just require a brand new approach, and we have to do things differently. The first thing we have to do is really a change in culture, because traditionally what has happened is, so we have development, they're working on their applications, right? They're doing all their testing, functionality testing, etc. And at some point in time in the life cycle of the API or the application, they will go to security and say, hey, this is this application, go and analyze it and tell us what's wrong, right? And usually this happened more in like what we call throwing over the fence way. So something was coming out of development, we'll just throw it over the fence to the security guys that will then do their job, and then the operation guys will deploy this. So there's still this like silos between development and security. Now, in terms of collaboration, we really need now this to change a lot because we absolutely need security to be involved way earlier in the life of the applications to be able to do their jobs efficiently. And we need development to actually be more security savvy and have the right tools to actually look at security earlier in the life cycle of the apps, right? So we need this collaboration. We need processes, we need the way to do this and automate this. So we need new tools to be able to inject security as early as possible in the life cycle of our applications. And we need the right tools. So one thing about shifting left, right? Shifting left is about using, inserting, security as early as possible in the life cycle of our APIs or applications. Now, this imposes a change of tools. It is not going to work if you try to take the tools that the security teams are using today and try to put the security tools in the hands of the developers and tell them, okay, you developers go and use our security tools, because that just doesn't work for developers. They need to work with their tools. which in their development flow. So we just need to give them the means to work with security, but in their development flow with different tools that are adapted to the way they work. So security guys keep their tools, and when they have to use them in the flow, that's great, but we'll need to give some new security enablement to developers for them to be efficient. So what have we done at 42 Crunch is when we started this company, we looked at, okay, there's like this big ratio between developers and security. There's like 100 developer probably for one security guy, if you're lucky enough, probably in a large enterprise, right? So how can we leverage that the development community to work on security, right? And one of the key problems always has been in security, how does my application work? What is the data which is moving through this application? Can I describe that in a way that I can say somewhere, hey, this is my application, that's the way it works, and anything that doesn't look like what I'm telling you what this application does, then basically should be blocked, because that's not what I'm expecting, okay? So in security terms, this means taking more like a whitelist, a positive security approach, as opposed to taking a blacklist approach, where I'm just looking at everything coming my way, and I say, okay, out of this stuff coming my way, there are things that I know are probably potentially attacks, so I have some signatures for those, and I can find those signatures in the amount of data coming through, and then stop whatever I deem is actually potentially a problem. So what this means is every time there is a new problem, then we have to go back and fix those rules, and making sure that until we have these new rules, basically that new attack can actually come through. So by definition, in security, the other approach, which is to take a positive security approach of saying, this is what I'm expecting, that's exactly the data and the endpoints and the APIs I'm going to expose, and I know exactly which data will come through, which requests will come through, and I know exactly which responses will go back to the callers, to the consumers of my APIs. And we're lucky enough in the API world to have this de facto standard, which is OpenAPI. You may have heard of this as its old name, which was Swagger, which allows us really to describe exactly do that, right? It allows the developers, probably your developers, if you're a developer on the call, using this today to describe what your API does for documentation purposes, so that your consumer can know this is what my API does, and that's how you call it, and this is the answer and the responses I'm going to send your way. So really what we wanted is push a bit the envelope on the usage of OpenAPI to say, okay, this can really become now the whitelist of everything I'm going to accept, right? So my developers, they're going to do like most of the work here by describing what my API is actually doing, which flows, which information flows through it, the headers, the query params, the JSON structures, everything. And from that, we're going to automatically build this whitelist to be able to say, hey, this is pretty much the only thing the API is going to accept. So anything else, should it be bad requests or threats or whatever it is, we'll automatically push back, because it will never correspond to what we're actually expecting. So if somebody puts any injections in there or start calling admin operations we're not exposing, or trying to inject some data we have not described, or trying to evade some data we have not described, none of this is going to work, because it's not part of the whitelist, okay? That's kind of the core of what we do at 42 Crunch. OpenAPI is kind of the core of that functionality. So the idea of the platform is we want to equip the developers with the tools for them to start worrying and working in security as early as design time, okay? So educate yourself on what are the potential problems, on all those breaches, the things you have to watch out. You can learn from all of this, and that's why we created this, API security.io, this community site, so you can follow this and follow the best practices and recommendations that we push through to this site, right? Now, at development time, we're going to give you, this is what I'm going to demo in a few minutes, we're going to give you tools that allow you to evaluate in your OpenAPI Swagger file, how well is security defined. So we don't even need to have the API even implemented. This could be like an API design first approach, where we start with the API, we have not the implementation, but still we can already evaluate how well our interface is described and how security is described, and get the score, we'll see in a minute, of how well we're doing very early in the life cycle. And everything we find and can fix at that time, this is something very easy to fix, as opposed to fixing it when we get that deployment time, okay? So that's development phase. And from an integration perspective, so once, I'm a developer, I work in my world is my IDE, we'll do this demo with VS Code. In the next stage, I've written the implementation, I have a first version of my API, I'm gonna push it through my CI/CD pipeline, through Azure DevOps in this case, and then the same audit is going to run just to make sure we're, conforming with the minimal security requirement that the security teams have defined, such as this is, the number of, I don't want it to see any high or critical problems left in the report generated by the audit, and the minimal score is 80 out of 100. And of course, if the file is not properly defined, then we're going to block it. So we can put there a point of control. So every time there's an integration, we can block something that is not at the light level that we want. And then we can also test how well the implementation is doing compared to that contract. So you've given us a contract that says, this is what my API does. All right, so this audit I'm talking about is a static analysis, if you want, of the OpenAPI file. Then we can take that and we can invoke the API and see how really the implementation behaves and how it matches that actual contract. So if you're telling me that your API is supporting post on /register, right? If I'm sending you a put or a get, if I'm sending you data in the wrong format, I'm sending you an integer instead of a Boolean, I'm sending you data which is outside of the constraints that you have declared in your contract, how is your API actually behaving? So we're going to find all kinds of issues. Usually the happy path is usually well tested. What I call the hacky path is really not so well tested. And it's not easy to do. So what the tool will do is will generate all those tests automatically from the OpenAPI definition. And finally, if we pass that stage, then we can automatically protect and deploy protection in front of our API by deploying our API firewall, which will sit in front of your API, either as a sidecar if you're using something like Kubernetes, or as a normal reverse proxy in front of existing management solutions. So here it can be deployed on AKS in the Azure world, or in front of Azure API management. So that's kind of the full picture of the platform. Okay, so now I'm going to show you this in action. Let me just exit from here. And the first part, I'm going to show you this audit within VS Code. So this is a plugin that you can install from the marketplace from Visual Studio. Their link is here in this presentation. We're going to give you this presentation after, so it will be very easy for you to take this and install it. Okay. So once my plugin is installed, so this is my VS Code. I have here a number of different OpenAPI files that I'm working with. I just opened here one particular called Open Weather. And we are going to click on this little button here that says 42C. When we do this, what we do behind the scenes is we invoke this audit on our platform. We have a SaaS platform. So this tool here, VS Code plugin, is using our REST API to the platform, invokes the audit and returns a report. So what that report is, it has basically two parts, okay? There's two things mainly that we're testing for. The first one is how well security is defined. And here really I'm doing a really bad job because I got 0 points. And that's basically because the security is not defined at all, which happens quite often on the test that we're doing with customers, and we tend to forget about documenting in there how the API is actually secured. Is it basic auth? Is it an API key? Is it using auth? If it's auth, which type of grant type is actually using? So all of this you can express within OpenAPI, right? So here, what's happening is I don't have any security section defined. So let me have a look at what this API looks like. So I will see here, let me just get in there. Okay, and so this information here on the left is kind of a way of browsing more easily your OpenAPI file thanks to our OpenAPI plugin. And here I will see that effectively I have an API key definition. So I have defined that my API is secured through an API key. However, I don't have anything here in the security section, which basically means although I have defined security, I'm not applying security. So the system here has no way to know how the API or each operation is actually secured. So let me just add a new security section here, and we'll put API key in here, which is what we need. We'll save that and we'll run that again. And that should bring up my score quite significantly. So I've gained here 8 points, and I still have a big problem here. I'm transporting this information over probably maybe even HTTPS, okay? Anyway, so I'll have to go in there and fix most of those issues. Now, what else we're going to look in there? So data validation here, 45 out of 70. So what this is all about? This is about reporting. Let me see if I can close this to make some more space. Here we go. This is about reporting information related to the format of the data flowing through. So say I have this weather object here, right? Schema. So I have weather, it's an array, and inside I have objects, I have a description, an icon, an ID, and main. As you will see, each of those are just strings, okay? So what the report is going to tell you here is, okay, you're telling me this is a string. A string can be a lot of things, right? So it could be an attack, it could be just a short description, it could be a very long description. It could be that you don't want any special characters in there, so I need some more information about this, right? And you will see here to the right, the information I'm given is, okay, you don't have a maximum length, that's one of the problems. You don't have any patterns. For each of the problems that we report, you will see actually a description of what the problem is, how it can be potentially exploited, and remediation. So this is all part of this education I was talking about. It's all about learning about those problems. And what we see happening in our customers is developers, you know, they make that mistake maybe once, or they forget about it once, 2, 3 times maybe, but then they know that every time they put the string, then we have to put some constraints, right? So even if the original, the first scores they get on the audit might be quite low, around the 20 points or 30 points out of 100, the third time or fourth time they do this, they get straight into the 60s and the 70s because now they've been, you know, they're sensitive to the problem and they know what they have to do to remediate that problem. So in here, for example, for a description, I could say, well, I want a pattern, and we'll have some help here on the pattern itself. And let's say that the description is something like A to Z, so only specific characters and dollars, for example, and probably no more than 50 characters. And minimum would be, I don't know, let's say 5, okay? So that way I know now that description, it has a pattern, I know what it will look like, it has a max length and a min length. Now it has constraints, okay? So if I run this again, then the problems for this specific issue are going to disappear, and I gain a point, okay? And here you will see at the bottom the things that will bring you more points as you go and actually fix them, right? So if we fix this API ID, for example, here, and we put max length, let's say no more than 25 characters, and run that again, then we'll have like 11 points that we gain, right? Because this is like a core thing that we send in every request. It's actually the API key itself. So we want to make sure to protect that, right? So using this plugin and this interface, I can go and interactively fix all those issues until I get to a proper score, such as usually we say around 70, 75 is when you start to really have well-defined both the security and the data flowing through the actual API, okay? Now, once I have done that, then what my next step, right, if I go back to the presentation here for a second, so that's what the presentation does, the next step is really about automating this, okay? So the idea here is as I go and push my code into, in this case, GitHub, okay? We will do exactly the same we have done now, clicking manually on that button and getting that report, but we're going to do it in an automated way, okay? So let me show you what this looks like. So in here, I can close this audit and end the editor for this for now, right? So if I look at my files here, the Azure plugin that we have developed, this is a normal Azure pipeline in which we have this specific task. It's very simple. All it takes is an API token. So what this task will do is it will talk to our platform. We have to authenticate to our platform. This is done through an API, a token, an identifier token. So you need to have an account on our SaaS platform. You can self-register to actually do that if you want to test after this webinar. You will have to register there. You will create an API token and put it as a variable, as a secret variable inside Azure DevOps, right? And then we'll have this collection name, which is where we're going to upload our API files. And then we have this minimal score. So at the very high level, what is the minimal score that we want for our OpenAPIs to pass that task and pass that test, okay? And here it's set to 75. But we also introduced this configuration file to go a little bit further than just saying, okay, I want 75. And the first part of the demo, I'm going to show you what we call the discovery mode. So we have a lot of people coming and talking to us to say, I know I have APIs all over the place inside my repos, whatever they are, right? And I really don't have any central place across all my teams where I can see all my OpenAPI files and all my APIs. So I know what is it that, what are all the APIs across the enterprise, right? So we created this discovery mode, and what this do is it will crawl your repo, and it will go and find all the Swagger files it can find in YAML or JSON format, and then automatically analyze them and push them to our platform, so you can have this visibility of all the files and the level of security that they have, okay? So in here, what I've done is simply say, okay, you can see here I have OAS files, simple OAS. So I've put the root of this OAS file JSON. So it will go and crawl all the subfolders from OAS files, as well as the OS files entry itself. Okay, and then it will not fail if the contract is invalid, because we want to see those inside our UI. And it will fail if any of the APIs have issues which are at critical or high level, critical high level, sorry. So what we're going to do now is simply push this to our GitHub environment. So I will just commit this change. We'll call it full discovery mode. Okay, and I will check that. All right. and then we'll just push this. Right, so now if I go to Azure DevOps, in here I have the same pipeline that we've seen before. And we will see now full discovery mode, and our job just started. So this may take a few seconds. I guess all the UAS came into working now, so maybe less pool of images available. But meanwhile, I'm going to show you here. So in our SaaS platform right now, I have only one collection called webinar, okay? And what this will do now is it will create a new collection called webinar discovery with all the OpenAPI files it's going to discover as it crawls that GitHub repository. So it will take a few seconds. It has check out the webinar repo, and now it has found 8 files. Okay, so that task has failed because we have all those files and their score is below the required value of 75 for pretty much all of them, right? Except one, which is here. And then you can see here from the logs, you can actually click on this link and it will take you straight into the platform. And here you will see there's a new collection we have created now. So think of a collection as a way to group your APIs. And we have a new collection with those 8 files that have been discovered in here. Each of them with their score, and they're all valid files. Okay, that's great. And the number of problems that we have found. So if we take any of those, let's say this one, for example, we will see the same report we have seen in VS Code, except it's now displayed in a different way in our environment. And I see the same thing, number of security issues, a number of data validation issues, as well as what is the problem and details of all of that. So we have now a great overview of all the different APIs that have been uploaded, and for each of them, you know, what are the problems and the original score, okay? So that helps me find and report on all of those. You can also automate this if you wanted to, like do a batch import of that through the REST API. If you don't want to do this from CI/CD pipeline, you can do this in every single repo. So you have that flexibility to discover this way all your different APIs within all your repos if you wanted to. Okay, so that's the kind of the discovery mode. Now, as you've seen from here, if I go back to my logs, right, we failed that step here because, of course, all the files that we have found are below the required minimum, and therefore, well, we blocked. So we couldn't go to the next step, which is basically to enable our firewall in front of our APIs. So let me do this now. Just going to go back to VS Code. And we're going to change that file that we had, that conf file that's now on discovery mode. We're going to change it to be in mapping mode. So this is a bit different, and you can combine the two approaches. For the sake of the demo, I've just separated them too. And what this now will do instead, so let me just copy that in here, it will say, okay, whenever you don't do discovery, okay, I have my APIs, I know what they are, I've already imported them and they're managed through the platform. But every time you find this specific file, go and update the API with this UID in the platform. So let me show that to you here. If I go to the platform, I have this webinar now instead of webinar discovery, in which I have an existing API with this UID 757, etc. Right? And if I go here, I will see it's exactly the same ID. So everything within the platform has a specific unique ID that you can use to uniquely target any resource. Okay. So what this will do instead, it will go find a specific file and update the one in the platform, and then because this one is actually of good quality, we'll go to the next stage, which is to deploy automatically the protection. So that's also very critical from an automation perspective, right? Because one of the key problems also we see with customers is usually the protection and the security. We only really worry about it and we put it in place when we get at maybe pre-production and of course production levels, right? But we tend to forget and test always with security on. If there is something we can really highly recommend you to do, is to deploy all those security measures as early as possible. So you always test with security on, you always test with all the right enforcements and API keys in place and auth in place. So you don't discover all those problems linked to security very late in the life cycle, right? So it's very easy in our platform to put this protection in place very early, and as early as dev mode, even in the mockup if you want to. So we always test and work with security on as opposed to security off, okay? So what the task is going to do now, I have an environment in Azure on which I have our runtime, which we nickname Guardian, which is installed here but not running because it's not protecting anything yet, right? And by doing the deployment now, we're going to activate this and put security in place, okay? So all I have to do is take this COM file, I'm going to save it, and I'm going to push it to our GitHub. So this is like mapping only mode, let's call it this way. Mode, not model. All right, and we'll push that. We'll then go back, this is the same thing, this is gonna kick our pipeline. Will be a new instance of it. Should come in a few seconds. Here it is. So same thing, we'll have our job. It'll take a few seconds to actually start. And once the job is starting, it will do exactly the same audit, except it will do it only on that specific known API. And then it will take the files and push them into that Firewall VM. This time, this is green, right? Because the actual score is 89. If I click here, I'll go straight into the platform and I will see that it is 89. And we actually have updated, you see here a few seconds ago, the original one that I showed you before, okay? And if we look at the logs again, we'll see we have copied basically the OpenAPI file straight into our VM. And what this triggers is the automatic configuration of that VM to protect our API. So if I go back now to my terminal here and I do status again, now we can see that our runtime is actually active. So we have put it in place. And just for the sake of showing you that it works, we have this runtime here solution. So if I'm sending, well, let me just get a new one, a proper request to my API, then it is going to work. If I'm sending some wrong data to it, right, then this is going to be actually stopped, right? And the only thing we had to do to get that is just to take our OpenAPI file and push it into and use it straight as the configuration on Firewall to just create this ultimate whitelist that we're validating against. Okay, and this kind of concludes the demonstration. And I will just finish the presentation to hopefully we have convinced you that automating security is something you have to do, simply because as the sheer number of APIs increases, there's no way you'll be able to manually keep up on security unless you actually automate it. This will allow you to scale security, to make security as agile as development is. You will detect all those problems early in the life cycle, which will make them much easier and less costly to fix. And of course, the key benefits of having this OpenAPI definition with the proper contents and at the right score and detect that early is you can then take that and automatically use it to protect your APIs also in a automatic fashion. And Christine, this is what concludes my presentation today.
Thanks, Isabel. We have a few questions that came in. So I will start here. I know this API security audit requires a token to call it from VS Code. Is there any limitation on the number of calls or licensing associated?
There is a limitation on the 3 calls per minute. That's all. So you basically, you download the, you install the plugin, you give your email address from the plugin. This will trigger an enrollment in the platform. You will be returned a token. You put that token into the VS Code, and then you'll be able to audit as many files as you want. So it's not a limitation in the number that you can do, but rather the rhythm at which you can actually do them, which is 3 per minute.
Okay, thank you. Next question. Is there any software that can generate an API file for code written in any programming language?
Absolutely. So there's a lot of programming languages. Should it be Java? Should it be Node.js? Should it be, Spring Boot frameworks or Bootstrap that support annotations that you can add to your code, and then from those annotations you can generate the OpenAPI file. You can actually do and generate a really good OpenAPI file by just annotating your DTOs, your data objects, and your API requests themselves. And if you want to know more about that, I would recommend you go to the Smart Bear website and look for Swagger tools in general, and you will find a lot of references to those frameworks and annotations you can use to generate this file.
Okay, next question. I missed how 42 Crunch platform connects to Azure DevOps. Can you remind me about this?
Sure. So let me just maybe go in here. So it's really at 2 levels. So this is the platform really with all the different services that I've been showing. So the audit or talked about, the scan and the product, right? So what we have done is we've created plugins for both. So VS Code that talk to our REST API and obtain this information. So when you click on that button in the IDE, what happens is you invoke this REST API that invokes our service and returns the report. When you execute this task from Azure DevOps, it does exactly the same thing. So that task that's available, you can put in your existing pipelines. It will call our platform, run the audit or the scan or the configuration of the protection, and then it will return its results. So that's the connection between the two, is those plugins we have created for those different environments and that invoke our platform through its REST API.
Great, next question. This is a really cool plugin. Is there one available for Java developers like IntelliJ or Eclipse?
So IntelliJ is something we have on the roadmap. It's probably be a couple months or more before we actually release it, but it's definitely a roadmap. Eclipse is a more longer roadmap, I would say, at this point. But IntelliJ, absolutely.
Okay, and last question. Is this a cloud service? How about privacy? How will my data be handled?
Very good question. So our SaaS platform basically has been built with that in mind. Every single user gets their own tenant. Each tenant has its own data, which is encrypted with different keys per tenant. So when we onboard a new tenant and a new user, we'll create on the fly those encryption keys, and we use that to actually encrypt your data. So even if somebody could get into a side tenant and they will not be able to actually look at your data because they don't have the same key. It's also, it's been really built with security in mind. We have a very strong multi-layer architecture where the data is really at the back, and there's no way to actually get to that data straight from the front layer. And it uses something similar to what a service mesh would do to enforce the authorization among the different services and the different layers within the architecture. If you're really concerned by this, so please send us a mail and we can send you a presentation that explains exactly the architecture.
We just had a question come in. Do you have plans to make on-prem version of your platform, or at least the audit service?
So the full platform in itself for enterprise customer is something we can, we could have a dedicated instance just for you as a customer, most likely operated by us, and it could be in your own data center in cloud. Again, if this is something of interest to you, please come to us after this webinar and we'll be happy to discuss. And then the audit today is really, it requires to have the platform indeed, because that's also where we push the report, and that's where we're going to do historical information and the evolution of your score, etc. So at this point, we don't have plans to do the audit like an individual audit that would not require the platform. It will have to go through our API.
Okay, one last question just came in.
Mm-hmm.
Will there be support for other cloud vendors in the roadmap?
Absolutely. So we're working very closely with Microsoft here, but there's nothing specific to Microsoft and what we're doing. You could take our runtime, so this plugin, for example, that we have for Azure DevOps. We can do the same thing in GitLab. We can do the same thing in Jenkins, or we can do the same thing in Bamboo. And a mix of those. And the runtime itself can really run in any Kubernetes environment. It's not tied to the Azure platform. And actually, yeah, there's nothing specific here apart from some specific integration. One we run in Azure, then we'll integrate with their insights and monitor, et cetera, but we can do the same with other clouds without any problem.
Yeah, if I could chime in here as well. People use VS Code to build and develop stuff that's deployed on-prem into AWS, into Google, into DigitalOcean, all sorts of different places, right? And Azure DevOps is used to build and deliver solutions into all different cloud vendors and on-premise options as well. So, in either case, whether we're talking about the 42 Crunch solution or we're talking about Azure DevOps or VS Code, right? Those there's no lock into Azure in particular there.
Great point. Thanks, Steve.
Sure.
All right, guys, so we're coming to the top of the hour. So we're going to wrap this up. If there are any questions that we did not get to, they will be included in the follow-up blog. I'll send out an email to all of you with the recording and a link to the blog. And the slides will be included as well. Somebody asked about that. Is there anything else you'd like to add, Isabel?
No, it's just thank you very much, everyone, for joining us, and we're looking forward to working with you all.
Great. Thank you, guys. Stay safe, stay healthy.
Indeed. Take care.